Marlow starts from rest and reaches a final velocity of 10 meters per second east. If he accelerates over 5 seconds, determine his acceleration. So for any word problem, excuse me. Actually, for any word problem, this is the particular format that I want you to use. Okay, you start with the given. So identify the givens. So what are the given quantities you have? And taking note that acceleration, velocity, and displacement have direction. So maybe perhaps it's also good to identify uh, at the start where would be your positive direction. So positive direction is upward, positive here, this is negative, and yeah. Again, conventionally, we just use the Cartesian coordinate system for that. It's just much easier to, at least it's just much easier for you to remember, okay? So you start with the given. So to identify the given here, this is the usual case. In a word problem, they will not explicitly say that the initial velocity is 0, but they will say it starts from rest. So if it starts from rest, it tells you that the initial velocity is 0. Okay? So that particular phrase will give you the initial velocity. Okay? And although it's quite clear here that the final velocity is given by that. Okay? So you're gonna take note that the final velocity is 10 meters per second. So 10 meters per second east. And remember that when we try to do computation, it's much easier to compute certain things if we're gonna interpret the direction in terms of positive or negative sign based on our coordinate that we use. So instead of just placing 10 meters per second east there, I will place positive 10 meters per second. Okay. So again, east, remember east is here. So it's to the right. So therefore, I will use that particular notation that it's positive. This is same thing as direction of east. Okay. So again, it's just much easier in our computation if we just use positive or negative sign. And for the time being, in our case, we'll just be dealing with one-dimensional motion, so it's much easier because you will not have to deal with north and east or something like that. So it's just east or west or vice versa. So much easier to just indicate that one, okay? And then if he accelerates over 5 seconds, so that 5 seconds is your delta t, or just t, 5.0 seconds. So now we need to identify the acceleration. So I can just write that a is being asked. For your solution part, so you always start with your equation, like a is equal to delta v over delta t, or this is just vf minus vi and over delta t. And by the way, in my computation, try to take note that you have to specifically indicate the direction also. But then again, we use the positive sign to indicate positive direction and negative sign for the negative direction in our solution. So for VF, it is positive 10 minus 0, and delta t is 5 0.0 seconds. So if you're wondering, I didn't place the units here, okay? However, for any case that you have, like if you're using the standard units, like for velocity it's meters per second and the time is in second, automatically it gives you an idea that the final answer would be meters per second squared. Okay, so A would be positive 2 meters per second squared. And again, my final answer, the positive sign here indicates that it should be in the positive direction, which is east. So the final answer should be written as 2 meters per second squared east. So this would be my final answer. Again, I'll just replace the positive symbol with the direction itself. Positive in our coordinate system that we use is directed east. So therefore, the acceleration has a magnitude of 2 meters per second squared, and its direction is east. So are there any question with the first one?
What does the F and VF mean in the I and VI?
Just the final and the initial.
Oh,
So
okay.
yeah, we can just use I for initial. And F is the final. Okay. So by definition, if you have delta symbol, delta means, or delta means final minus the initial. It's always like that. So final state minus the initial state. So if you can see the symbol here with any expression or equation, you should start with the final and then subtracted with the initial state. And yes, you cannot have VI minus VF because that's not the meaning of delta or change. You should always subtract the final with the initial. Okay, so you cannot interchange these two. That's why it's very specific final. So from the start itself, it's very important for you to know where is your final and the initial. Because if you interchange that one here, if you can see, you can get a negative value, and that's not the right direction of your acceleration. Are there any other clarifications? So can we proceed to the next one? Okay, so a ball is rolled up a hill with the initial velocity of 5 meters per second. If the ball experiences an acceleration of negative 0.75 meters per second squared, how long will it take for the ball to stop? So I'm just gonna take note of the things that is given to me. It's rolled up a hill. Initial velocity is 5 meters per second. The acceleration is given as negative 0.75 meters per second squared. And the question is how long? Okay, how long will it take the ball to stop? So you have another word that tells you something. It stops after a particular time. So it would always be advisable if you can draw up the situation of this whole problem. Like you have a ball going up, maybe you can draw a hill, something like that. Okay, so you have a ball rolling upwards. Okay, so that means that since the initial velocity is positive, that tells you that going up is the positive direction. Okay, so going up the hill is the positive direction. So that means that opposite to that one would be the negative direction. So I'm gonna take note of the things that is given to me. So I have initial velocity, so that would be my VI. That's positive 5.0 meters per second. Again, the positive sign indicates that it's moving up. Again, I use that convention. And the opposite of that one is just going down. And then what do you think is my final velocity here? What do you think is the final velocity? Anyone?
0.
It should be 0. Where do you get that particular case? Well, it's stop. So these are the things that you need to be aware of. Okay. So 0, it stop. So therefore, automatically 0. So at some time, it will eventually stop. And for now, we're just not after to explain why is that it stops. But again, we just try to examine its motion for now. And what else? We're given A as negative 0.75 meters per second squared. So it tells me that if this is up, this negative sign here tells me that the acceleration is down, okay? Down the hill, not necessarily vertically down, but it depends. Again, the motion of your object is just going up or here. So this is up, this is down. So the direction of the acceleration is downward, okay? So now we need to know how long does it take. So it tells you that you're solving for the time, okay? Or delta t in our case, delta t or t, it's the same thing, okay? So now for our solution, we always start with the equation that we have. We know that by definition, A is Vf minus Vi over delta t. But I'm solving for delta t. Well, uh, actually, I already checked your unit test, and most of you have the mistakes in the part of solving and manipulating equation. So, but there's another way of doing that one. Not necessarily that you start with this one and then you need to solve for delta t. What you can do is you can substitute the values first. That's okay. And then solve for the unknown. So if I'm going to do that, that means that I'm just going to replace my a with negative 0.75. And if I notice everything is, well, velocity is in meters per second. This is in meters per second squared. So delta t, I should expect that the answer is already in seconds. So therefore, I can get a way of not necessarily placing all the units here. Okay? So, because sometimes that confuses you with a lot of letters as well as the numbers. But since everything here, acceleration is in meters per second squared, velocity is in meters per second, I should expect that when I solve for time, automatically it gives me second. So now, just place the values that I have. So VF is 0, and this is minus the positive of 5.0 all over delta t. Okay, so if you can see here, this is should I expect. I only expect that I only have one variable in my equation. Otherwise, I cannot solve the equation, right? So I'm gonna solve for delta t, but if you can see here, sometimes it's much easier to solve if you see the numbers. So you have here negative 5.0 all over delta t. So I need to solve for delta t. How would I solve for delta t? Well, I need to separate this one. To do that, I'm just gonna multiply both sides by delta t. Because doing so, this cancels out. So this gives me negative 0.75 times delta t is equal to negative 5.0. To, to solve for delta t, I'm gonna divide both sides by negative 0.75. That gives me just delta t. Delta t is equal to, so if you can see here, my final answer is positive value, which is to be expected. Remember that time doesn't have a particular, it's a scalar quantity. So you should expect that the final answer is doesn't have any signs, or it's not negative. So it's another way of looking at that your answer, if your answer actually you follow, you answer it correctly, your solution is correct. Okay, so if you can see there, time, it will stop after 6.7 seconds. Okay, so before moving on to example number 3, are there any questions with example number 2? If there's none, again, you can do it this way. I know that there are some that are more like you're more comfortable doing this one, like dealing with numbers instead of just dealing with the variables first and then solving for a particular variable. So if you find this one much easier, yeah, you can do this part, or you can do this particular thing. Because if you're gonna solve this one first before you substitute the values, you can just have delta t is equal to vf minus vi all over a, and you should get the same answer. Okay, so if you find that you're comfortable solving for the variable first and then substitute the things that you have, that's fine, as well as here. And again, I know that in some cases, some teachers will like to see the units here, but in my part, I would consider this particular solution without necessarily showing the different units. The purpose of having the units, though, is that it can also check your solution if you come up with the correct expression. Like, I should expect that the final unit is in second. So sometimes with the if you have the corresponding units in your solution, you can actually check, because you can cancel out all other units except for second in this case. But then again, in my case, I just usually tell my students that maybe perhaps if the velocity here is given in centimeters per second, just convert that one to meters per second. I think it's much easier. And then just use the meters per second for the velocity to solve whatever is the unknown quantity. Okay, because sometimes it could mess up your a lot of letters, combination of numbers and letters. But then again, the purpose of writing the units is actually also to check whether our units are consistent with our final answer.